So the last few classes we've been talking about acids and bases, and we've been mentioning that acids have this low pH and bases have this high pH. But what is pH really? So a little side note again. Remember, we should be trying to convince everyone else that this is pronounced p or poof instead of pH. So a little extra credit if you can start doing that. So what is pH? It kind of stands for the potential of hydrogen or hydronium there, which is really like the concentration of it. So just to get us started, I just want us to think of pH as a measure of hydrogen. And we're going to quantify this in a minute here. Let's go back to the picture portion of our notes though, and let's draw out a little logarithmic scale here, starting in the middle with a neutral pH of 7. So from the simulation, I hope we saw that at a pH of 7, the concentration of H plus will be equal to the, and this could also be H3O plus, will be equal to the concentration of OH minus. Now the pH scale is used with this log base 10 system. So that means when we move up, every number we're moving up is actually an increase of 10. So it's 10 times that substance. So when we go from a pH of 8 to 9, we'd say the pH is higher, it's more basic. It's actually 10 times more basic. And we'll quantify that in a minute and say what that 10 times actually is of. So when you go from a pH of 9 to 10, a pH of 10 is 10 times more basic than a substance with a pH of 9. Now, going this way, what if we made two jumps? Well, 8 to 9 is 10 times, 9 to 10 is 10 times, so that means it's 20 times, right? Oh no, wait, 10 times 10. That would be 100 times more basic. And, we're going to do all of this up to about a pH of 14. Now, what about moving the other direction here? So a substance with a pH of 6 is acidic or slightly acidic, and then a substance with a pH of 5 is more acidic. So how much more acidic is it? A substance with a pH of 5 is 10 times more acidic than a substance with a pH of 6. Moving down, a substance with a pH of 4 is 10 times more acidic than a substance with a pH of 5. And I could also say that a substance with a pH of 4 is 100 times more acidic than a substance with a pH of 6. And we could take this all the way down to 1 or 0, or maybe even, theoretically a negative value, just something very, very acidic. Okay, let's come back here and let's figure out how we can quantify this and turn these pH numbers into actual values of what's there in solution. So pH is going to equal the negative log of the concentration of these hydronium or hydrogen ions in solution. So pH is going to equal the negative log of H plus. Now I'm going to write this over here. Because weak acids and bases do not dissociate completely, we cannot do these calculations with weak acids and bases, only with strong ones. Now, if we were trying to isolate H plus and we learned in math what a log function really is, we'd know that to do the opposite of a log, to cancel that out, we'd be raising this to the power of 10, or 10 to the power of this. So we take this negative sign, we put it up here, and the concentration of H plus equals 10 to the negative pH. So if we were trying to do the opposite of that. Okay, there's also actually something we don't talk about too often, a concept called pOH. This would be very similar to this concept. It's just the negative log of the concentration of OH minus ion in solution. And then again, to do the opposite of this, to find out what is the concentration of OH minus, we would do 10 raised to the negative pOH. Now all of this works because water has this thing called a Kw of 1.0 times 10 to the negative 14. And what this means is that water has the concentration of H plus of 1 times 10 to the negative 7, and the concentration of OH minus, remember, is equal to the concentration of H plus in pure water. So if we know the concentration of one of these two values, and I'll tell you that they are always equal to this, we can always find the other. And again, if mathematically you were trying to do the negative log of all these things, we would find out this. 14 is equal to pH plus pOH. Now, using these 6 formulas here, we can find out any one value we're asked if we're given one more, or if we're given just one. So let's check that out with this practice table below, and I'll show you how to do these on the calculator. Okay, remember, this is only for strong acids and bases we're doing these calculations. So let's start in the first table here. It says that H plus is 0.1 molar. So I'm just going to go over here, and I'm going to say if the H plus is 0.1 molar, and this times OH minus is 1 times 10 to the negative 14, I'm going to go 1e negative 14 divided by 0.1, enter. And we see 1 times 10 to the negative 13. Now, or here, I'll wait till I get to the end for that. Now, how do we get from H plus or OH minus to pH? To go from H plus or OH minus to pH and pOH, we do the negative log of the values. So I'm going to do the negative, push the log button on the calculator, 0.1, enter. And we get a pH of 1. Now there's 2 ways you could calculate this, and either one will be good. You could either do the negative log of this value, or you could do 14 minus pH. 14 minus pH is a little easier. I can do it in my head. That's just going to equal 13. Now, is this solution an acid or a base? This would be a pretty, concentrated or high, low pH acid, pretty strong acid here. Now, I want to emphasize this. Just because the solution is acidic doesn't mean it has no OH minus ions. It just means it has a very low concentration of OH minus ions. Okay, let's do the second one. If I know OH minus, I can always calculate H plus by using this formula right here. And I can just do 1e to the negative 14 divided by 1.2 e negative 3. Enter. And we get 8.333, 8.3 times 10 to the negative 12. Now, on your scientific calculators at home, I want to remind you that the E was probably this little button that looked like this with 2 capital E's. That's that little exponent value. Okay, now how do we go from H plus to pH? We do the negative log of it. So let's do the negative log of 8.3 E minus 12, and we get 11.1. I guess maybe just 11 with sig figs. I'm just going to go to 1 decimal place. So we get 11.1, so this is a basic solution. And then OH minus, we do the negative log of 1.2 times 10 to the negative 3. And we get 2.9. And then we could kind of check our work. Do these two values add up to 14? Yep, they do. And if they were a tiny bit off, it's probably just due to some rounding error along the way. So with a pH of 11.1, this would be a basic solution. And again, notice that we do have some H plus in the basic solution, just a low amount of it. Okay, let's resume. How do we go backwards now? If my pH is 4.2, I'm going to do 14 minus that. So my pOH would be 9.8. And then to go backwards to these concentration values, oops, I'm going to make sure you got molar in there. I'm going to do 10 raised to the negative 4.2. And we need to make sure that negative value is in there. And we get 6.3 times 10 to the negative 5th molar. Now we could also divide this from 1.0 times 10 to the negative 14, or I can just do 10 to the negative 9.8. I'm going to do 10 to the negative 10 raised to the negative 9.8. And I get 1.6 times 10 to the negative 10 molar. So this would be an acid. Down here, if the pH is 1.3, we subtract that from 14, so the pOH would be 12.7. To move backwards, we do the 10 raised to these negative powers. So 10 raised to the negative 1.3 is equal to 0.05. remember, this would be 5.0 times 10 to the negative 2. That's a pretty high concentration of H+. To find the concentration of OH minus, we could do 10 raised to the negative 12.7. And we get 1.995. I'm just going to say that's about 2.0 times 10 to the negative 13. This is also an acid because the pH is less than 7. If the pH is pOH is 5.9, that means the pH is 8.1. And then moving backwards, if pH is 8.1, 10 raised to the negative 8.1 is 7.9 times 10 to the negative 9. And if pOH is 5.9, that means the OH minus concentration is 10 raised to the negative 5.9, 1.3 times 10 to the negative 6. I hope this is reinforcing that with the substance with a pH of 8 is a base, and that bases always have higher OH minus concentration than H plus concentration. That's one way to describe them. Okay, the last two. If the H plus is 3.7 times 10 to the negative 12, I'm going to do 1 e to the minus 14 divided by that. And I get 2.7 times 10 to the negative third as the concentration of OH minus. And then to go to pH and pOH, I'm going to do the negative log of that. Negative log of 3.7 e minus 12 is 11.4. And now that I have this, rather than do the negative log of this value, I'm just going to subtract it from 14, and you get 2.6. So with a pH of 11.4, that is also a base. And now this last one. The OH minus is 1.0 times 10 to the negative 7. Let's do that. 1e minus 14 divided by 1e minus 7, and we get, oh, check that out. It's still 1 times 10 to the negative 7. We then do the negative log of these two values, and we get the pH is 7, which means the pOH is also 7, because these two values always add up to 14. So what is this? I guess this would be a neutral solution of probably pure water or something of the sort. Okay, I hope this helped you get started. I'm going to now make a different video just to give you a little break of these practice 2 problems, and I'm just going to have an answer key above for you to look at while we're doing these practice 2 problems, so you could pause it and look at the answers.